Allora, buongiorno, noi riprendiamo i nostri lavori, quindi per i membri dell'Accademia è l'inizio della parte, possiamo dire, pubblica del workshop, ma diamo anche un particolare benvenuto ai molti partecipanti che si sono iscritti per questo workshop, che non sono membri ma che sono interessati all'argomento, e un saluto a chi è presente in sala, ma molti sono anche collegati online per partecipare ai lavori di questo pomeriggio e poi di domani. Ricordo chi avesse bisogno sempre ancora di informazioni pratiche che è possibile l'accesso wifi e quindi trovate le credenziali, i criteri presso la registration desk oppure presso anche chi distribuisce le cuffie per la traduzione simultanea. Ricordo sempre che la traduzione è in 4 lingue e quindi trovate i canali 1 italiano, 2 inglese, 3 francese e 4 in spagnolo. E ricordo anche durante la pausa caffè o in altri momenti è possibile qui al piano terra andare nella poster room, nella stanza dei poster, dove abbiamo circa 20 poster interessanti sugli argomenti che stiamo discutendo in questi giorni. Infine, questa mattina abbiamo letto il messaggio di Papa Francesco, firmato dal Papa dal Policlinico Gemelli, 26 febbraio 2025, e sarà domani distribuito anche, quindi troverete le fotocopie in italiano e in inglese. Chiaro che nel sito Vaticano lo trovate anche in altre lingue per chi fosse interessato. Così come sono disponibili anche qui alla mia sinistra, nell'atrio, anche diverse pubblicazioni dell'Accademia che possono interessare e che esprimono un po' i vari argomenti di cui si è occupata l'Accademia in questi anni. Iniziamo questa sessione con l'indirizzo di apertura di Monsignor Vincenzo Paglia, Presidente della Pontificia Accademia per la Vita, che apre questa parte importante dei nostri lavori.
Grazie Don Renzo. Il mio primo pensiero e il nostro va a Papa Francesco, che non ha mancato di farmi sapere la sua vicinanza a tutti noi e a questa Assemblea. Noi ci troviamo nel mezzo di un cambiamento d'epoca con emergenze globali che mettono in pericolo la stessa sopravvivenza dell'umanità. Per la prima volta nella storia che noi conosciamo, l'uomo può distruggere se stesso e l'ambiente, a partire dalla bomba nucleare, come abbiamo visto nel 1945 ad Hiroshima e Nagasaki, a seguire con il riscaldamento climatico e le drammatiche conseguenze se non si interviene in maniera opportuna, e infine con la potenza delle tecnologie emergenti e convergenti che possono modificare radicalmente l'umano. Io ricordo ancora quando nel 1919 lo scienziato giapponese Ishiguro ci parlò della nostra generazione come l'ultima generazione organica. Ve lo ricordate? La prossima sarà al litio. Io immagino che tutto il mondo andrà a cercare il litio dove si trova, ma al di là di questo, certamente ci troviamo in un momento particolare, perché a queste drammatiche prospettive che mettono in questione l'umano si aggiungono le molteplici altre sfide che dobbiamo affrontare: la crescita delle disuguaglianze e della miseria, la crescita delle morti di milioni e milioni di donne e uomini anche per fame. E come non essere preoccupati per la diffusione di regimi dispotici che violano sistematicamente le libertà fondamentali e gli altri diritti proclamati in tante corti internazionali. Intanto il crimine organizzato e le economie illegali, che mostrano una particolare vitalità, continuano a svilupparsi. E poi il dramma di milioni e milioni di migranti che fuggono da queste tragedie, che vengono però respinti sino all'eliminazione fisica. E così oltre. Siamo immersi in una policrisi, come ama dire Moren, un termine che il Papa Francesco ha fatto suo nel suo messaggio. Tutto ciò, a mio avviso, deve provocare un sussulto di pensiero. Lo scorso anno, in una ricerca del Censis, si parlava degli italiani come sonnambuli. Forse non solo gli italiani, però di sonnambulismo in giro ce n'è molto. È palpabile un clima di angoscia da fine del mondo. Del resto, il giubileo del 1300, il primo giubileo della storia, nacque per la sollecitazione di alcuni di diverse migliaia di laici del centro Italia che vennero a Roma in penitenza col cilicio e il camice bianco, si chiamavano i bianchi, flagellanti, perché loro immaginavano che nella notte dal 1299 e il 1300 ci sarebbe stata una sorta di palingenesi e loro invocavano appunto il giubileo. Il Papa Bonifacio VIII, che stava allora a Laterano, e la Curia Romana non volle parlare di giubileo perché sapeva di ebraismo. Di fronte alla scena di questi uomini che tutta la notte del 31 dicembre la passarono flagellandosi e pregando a Piazza San Pietro, Bonifacio VIII capì e indisse il giubileo il 22 febbraio, giorno della cattedra di Pietro, con data retroattiva al 1 gennaio. Il giubileo è l'inizio di un cambiamento d'epoca. Era questo il senso del giubileo ebraico. Ecco perché la scelta che abbiamo fatto su questo titolo, che avete visto, è cruciale, perché si tratta di scegliere tra la sopravvivenza dell'umano e della biosfera oppure l'estinzione dell'una e dell'altra. Una cosa però è chiara, che questa volta la fine del mondo non viene da un Dio che è diventato furioso, bensì dalla inarrestabile corruzione perpetrata dall'uomo sull'ambiente e sull'umano. Hans Jonas, riferendosi a disastri che derivano dal cambiamento climatico, ci ha avvertiti con un piccolo preziosissimo libretto dal titolo Sull'orlo dell'abisso, anche se facciamo fatica ad esserne consapevoli, tanto che crescono i negazionisti. Mentre si diffonde un atteggiamento rassegnato di fronte al presente, siamo del tutto privi di visioni unitive sul futuro del pianeta e dell'umanità. Karol Wojtyła aveva visto bene quando diceva: oggi l'uomo soffre soprattutto per mancanza di visione. Per parte mia sento bruciare l'interrogativo del cardinale e amico Carlo Maria Martini. Cito: oggi, attraverso un'informazione sofisticata, siamo caricati di problemi mondiali, senza avere le forze e le chiavi interpretative per rispondere. Questa è una condizione drammatica. Non abbiamo delle risposte globali. E quando pongo una simile questione, mi sento rispondere che questa è una domanda tipica della mentalità moderna, mentre oggi siamo nel postmoderno e non cerchiamo più le soluzioni globali. E concludeva: io però rimango con la fame di soluzioni globali. Certamente c'è bisogno di soluzioni globali, ma queste sono possibili unicamente se ci sono visioni globali, prospettive unitive per tutti. Ma dove sono queste visioni? E chi si preoccupa che esse vengano perlomeno avviate? Il tema della nostra Assemblea Generale, The End of the World, è volutamente provocatorio, da sfida epocale. L'immagine del diluvio universale, come narrato nel libro della Genesi, ci aiuta a comprendere meglio questo nostro tempo. Il punto di partenza del racconto biblico è la corruzione del mondo rispetto a come Dio l'aveva prefigurato con la sua parola creatrice. Si tratta di una corruzione causata dall'annullamento, dalla soppressione delle differenze, che si manifesta come caos, che confonde ciò che è vivo e ciò che è morto. È il linguaggio della tradizione sacerdotale. La professoressa Pellettier mi perdonerà di questa invasione al campo biblico. Dove è la professoressa? Non la vedo, c'è però. La componente distruttiva dell'agire e dei comportamenti umani mostra così tutta la sua carica di violenza, intesa come impossibilità di riconoscere, rispettare e sostenere le differenze che purtroppo vengono dimenticate. Dio, guardando l'umanità imbarbarita, si trova davanti alla difficoltà di significare al contempo la gravità della situazione divenuta insostenibile e la salvezza che vuole operare nel mondo. La strada che intraprende è di attuare da una parte un intervento distruttivo che in un certo senso rivela con più chiarezza la dinamica della violenza implicita nell'agire umano, e dall'altra alla sua volontà di salvezza corrisponde la grazia che Noè trova ai suoi occhi. Si realizza così l'apertura di un nuovo futuro verso la speranza, che la situazione che si era venuta a determinare oscurava completamente. Il racconto del diluvio si pone in questo crocevia tra la distruzione dell'uomo minacciata da Dio e la grazia di cui Noè, uomo giusto, gode ai suoi occhi. A ben vedere, una delle ragioni della crisi della nostra epoca è proprio il collasso delle differenze. Pensiamo alla scomparsa della figura dell'altro proprio mentre il nostro mondo è dominato dal digitale e dai rapporti di produzione che assolutizzano l'efficienza e la forza secondo una logica tecnocratica. La singolarità dell'altro, nella sua irriducibile differenza, disturba la circolazione di informazioni, di capitali e di prodotti commerciali standardizzati. La rimozione dell'altro, del diverso, lascia il campo al proliferare dell'uguale, che favorisce la massima velocità e funzionalità dei processi sociali. Ma dove è promosso solo l'appiattimento, tutto viene uniformato e la stessa vita si impoverisce, si appiattisce. Emerge sempre più quella che qualcuno chiama a ragione la dittatura dell'io. L'io, diventato imprenditore di se stesso, genera però angoscia e autodistruttività. L'esperienza e la conoscenza sono sostituite dalla mera informazione, le relazioni personali cedono il posto alle connessioni telematiche senza corpo e senza fiducia. Ma solo l'incontro con l'altro, che è anche destabilizzante, oltre che vivificante, può favorire l'elaborazione della propria identità, riconoscendone l'originaria costituzione relazionale. I teologi cattolici dovrebbero approfondire il senso di un Dio che non è motore immobile, ma Trinità generante, con il Figlio che è generato ma non creato. Tralascio queste riflessioni. La dittatura dell'io è una menzogna, fa sentire l'io unico e quindi deve essere senza rivali. È la grande menzogna che sta sgretolando il mondo. Care amiche e cari amici, è urgentissimo ricostruire la comunità umana. Di qui il primato dell'ascolto e dell'apertura all'altro. Il rabbino Jonathan Sacks, una grande figura dell'ebraismo britannico recentemente scomparso, ha parlato di un cambiamento climatico culturale, appunto una sorta di diluvio che ha travolto in noi dell'umano per ridurlo all'io. La sfida che abbiamo davanti è quella di ridare all'uomo e alla donna congiuntamente la missione originaria di essere assieme custodi della creazione e responsabili delle generazioni. Papa Francesco, con le 2 encicliche Laudato Si e Fratelli Tutti, ha delineato la visione di cui abbiamo bisogno. Ecco, in questo orizzonte vorrei sottolineare con voi questo pomeriggio 3 temi specifici che affronteremo nel nostro workshop e che possono costituire delle chiavi di lettura anche degli argomenti che verranno approfonditi dai relatori che si avvicenteranno in questi giorni, dalla nascita degli universi all'ecologia, all'antropocentrismo e così oltre. Il primo punto, pace e democrazia. L'angoscia del tempo presente trova nelle guerre e in una violenza diffusa una delle sue manifestazioni da fine del mondo. Io ricordo il sogno dell'89 con il crollo del muro di Berlino. Finalmente un mondo unito e universale, dicemmo in molti. Ho conosciuto personalmente Mikhail Gorbaciov e ricordo le sue parole sull'Europa come casa comune. Ho conosciuto personalmente Karol Wojtyła e ricordo la sua passione per un'Europa a 2 polmoni e fummo testimoni delle spinte unitive e del favore che godevano in quei 2-3 anni dopo l'89. Si fece la pace in Mozambico, furono firmati gli accordi di Oslo tra israeliani e palestinesi, accordi firmati. Finì l'apartheid in Sudafrica, 30 anni fa, Capisco che era il secolo scorso, ma solo 30 anni fa. Ci sembrava di sognare. Passarono appena 3 anni e sprecammo tutto, assistendo e sostenendo la guerra balcanica. Risorgono gli etnicismi, risorgono gli io. E la guerra balcanica non solo distrusse l'unione tra quei popoli, è diventata la balcanizzazione del mondo. Esplodevano i nazionalismi e iniziò una frammentazione che ancora oggi è difficile da frenare. E le 59 guerre in atto, quasi tutte, risalgono a questo problema. Non è questa la sede per indugiare sugli errori gravissimi di una globalizzazione del solo mercato, che ha creato squilibri crescenti e drammatici. Il primato dell'io sul noi ha preso il sopravvento senza che nessuno lo contrastasse ed eccoci oggi a guardare allibiti l'indebolimento delle democrazie avanzate e la crescita delle cosiddette democrature o le autocrazie. Troppi sono coloro che, individui, gruppi, popoli, Oggi, oltre a parlare di egoismo, si parla anche di, in italiano, noismo, l'individualismo di gruppi. E tutti viviamo in una condizione di spaesamento. E questo ci spinge a ripiegarci, ciascuno su noi stessi, ciascuno aggrappato alla propria zattera, illudendosi di salvarsi dalle onde gigantesche del diluvio individualista. Appare sempre più difficile preservare lo spazio del dialogo e della mediazione all'interno della società. Vengono pericolosamente ridotte le occasioni di dialogo, di collaborazione, di mediazione tra prospettive differenti. Eppure è proprio il pluralismo delle idee e l'articolazione delle diverse opinioni che rappresentano l'anima di una democrazia matura. Eppure, sempre più spesso si scende verso la deriva polarizzatrice con l'illusione di semplificare, escludendo l'ascolto e riducendo la complessità della dialettica nel contrasto amico-nemico. Ovviamente il primo con cui collaborare, il secondo da distruggere. Quando si innescano conflitti che feriscono e lacerano una società, quando si cerca di sostituire alla forza della ragione la violenza o la prepotenza del più forte perché sei il più ricco, quando si alimentano e si giustificano disuguaglianze crescenti e insopportabili, occorre riflettere per trovare la via di un percorso costruttivo. Si è insinuato nelle nostre opinioni pubbliche il dubbio che il potere democratico sia debole, inefficiente, lento, inadeguato a governare in realtà in veloce evoluzione. C'è chi pensa che addirittura sia un fattore penalizzante nella competizione con sistemi non democratici. Cari amici, stiamo attenti. È saggio pensare invece che le decisioni assunte nelle democrazie sulla base del consenso liberamente espresso dai cittadini e maturato nel confronto onesto delle argomentazioni, queste decisioni sono ben più radicate nella convinzione e non solo nella convenienza, che è invece spesso regolata da rapporti di forza e di prepotenza. La democrazia è garanzia di libertà, promuove benessere e sviluppo, costante ricerca della pace. Obiettivi questi negati dai regimi autoritari, incapaci di dare risposte alle speranze delle persone e in realtà esposti agli incerti equilibri di sostenitori opportunisti e quindi volubili, assai meno saldi e forti di quanto vorrebbero far credere. I famosi piedi d'argilla, di venerata memoria nel Primo Testamento. Va evitato che conflitti e radicalizzazioni artificialmente alimentati da chi pensa in tal modo di ottenere spazio e visibilità riescano a produrre una desertificazione del tessuto civile che lascerebbe campo libero ad avventure di ogni tipo. Permettete che di fronte allo sdoganamento della forza, allo sdoganamento del potere e del denaro, io ricordi queste parole di Dietrich Bonhoeffer, un grande credente, testimone della libertà contro il totalitarismo nazista. Scrive: Cristo fa non soltanto l'uomo buono, ma anche forte. Questa forza non è l'arroganza, non è l'aggressività, non è la prepotenza, non sono i giudizi, non è la forza gridata delle campagne elettorali, delle guerre, di chi fa carriera, di chi guadagna molto, di chi si impone o di chi si umilia. È la forza dell'amore, più forte della morte, dell'odio, della malattia, della povertà, delle dittature. È l'amore E l'amore, per definizione, è una forza debole, perché si dona e non si trattiene. Questa convinzione mi apre alla seconda riflessione: le religioni e la fraternità tra i popoli. Di questo ha parlato Papa Francesco nell'incontro interreligioso con i giovani a Singapore nel 2024. Tutte le religioni sono percorsi verso Dio. Le religioni, infatti, continua Papa Francesco, sono lingue diverse che esprimono il divino. Con questa affermazione il Papa intendeva sottolineare che ogni religione offre un modo per comunicare con Dio. Certo, non che tutte siano identiche o equivalenti in termini di verità. Infatti, le religioni si contraddicono tra loro alla superficie dei loro riti, testi sacri, dottrine e istituzioni, ma si incontrano nel profondo dell'umanità vissuta. Il dialogo più fecondo si realizza nella condivisione dell'esperienza della relazione con Dio. Continua il Papa, a volte noi pensiamo che l'incontro tra le religioni sia una questione che riguarda il cercare a tutti i costi dei punti in comune tra le diverse dottrine e professioni religiose. In realtà può succedere che un approccio del genere finisca per dividerci, perché le dottrine e i dogmi di ogni esperienza religiosa sono diversi. Così il Papa. La diversità è un dono di Dio. Se ci avviciniamo invece alle religioni da quella sorgente che è la ricerca dell'incontro con il divino, la sete di infinito che l'Altissimo ha posto nel nostro cuore, la ricerca di una gioia più grande e di una vita più forte di ogni morte che anima il viaggio della nostra vita e ci spinge a uscire dal nostro io per andare incontro a Dio, allora scopriremo che le religioni non si contraddicono, ma si dicono a vicenda. Poiché le religioni sono l'espressione della vita, cito il Papa, il desiderio di pienezza che abita il profondo del nostro cuore. Noi ci scopriamo tutti fratelli, tutti pellegrini, tutti in cammino verso Dio, al di là di ciò che ci differenzia, e sapremo ricercare insieme la verità, imparando dalla tradizione religiosa dell'altro. Così, Papa Francesco. La mia non breve esperienza di dialogo ormai più quarantennale dell'incontro delle religioni della pace mi ha mostrato la verità assoluta per esperienza di queste affermazioni del Papa. Io ho visto miracoli. Uno, lo dico con chiarezza, voi avete visto la firma della lettera sulla fratellanza tra Papa Francesco e Al-Tayeb. 10 anni fa questa firma sarebbe stata impossibile. Conosco Al-Tayeb assieme agli amici di Sant'Egidio da più di 15 anni. Un incontro continuativo di fiducia, di riflessione, anche di correzione fraterna ha portato a questa firma. I miracoli sono possibili. L'obiettivo del bene comune non è l'effetto di un algoritmo o di un calcolo di vantaggi. Bisogna favorire la logica dell'affezione reciproca che il cristianesimo fin dalle sue origini ha concepito come fraternità universale e interpretato come prossimità a tutti e particolarmente ai poveri. È un'indicazione impressa a caratteri di fuoco nel Vangelo. A volte ci sono sembrate indicazioni di buoni sentimenti, invece sta a fondamento della vita comune tra diversi. Ho avuto fame e mi avete dato da mangiare, ho avuto sete e mi avete dato da bere. In quel povero, in quell'assetato, c'era Cristo stesso, Dio. La fraternità indicata dal Vangelo è la via da seguire e da riproporre ovunque. Del resto, siamo tutti interconnessi e prima riusciamo a comprenderlo e a sceglierlo, prima saremo una vera comunità globale, riunita sotto il segno della fraternità. Dobbiamo comunicare questa prospettiva a tutti, nessuno escluso. Dialogare oggi all'interno di questa prospettiva, come noi vogliamo fare in questi giorni, significa trovare assieme le ragioni forti per rendere possibile la convivenza pacifica tra i diversi e rispondere in maniera adeguata alle grandi sfide poste dall'etica, dalla giustizia, dalla globalizzazione, dalla crescita della povertà, dalla crisi dell'ambiente, dall'avanzamento della tecnica e così via. Laici e credenti delle varie religioni siamo tutti chiamati a trarre dalle rispettive sorgenti spirituali e culturali ciò che abbiamo di più prezioso per trovare assieme nuove vie di senso. Paul Ricoeur parlava della ospitalità delle convinzioni. Se si scende nelle profondità delle proprie fedi o delle proprie convinzioni laiche e ci si mette sulla via del reciproco incontro, è più facile per tutti vivere e proporsi come luoghi di libertà, di democrazia, di pace, rispettosi della cultura e dei diritti dei popoli, liberi nella professione della propria fede e fattivi protagonisti della nuova stagione della storia del mondo, quella che porta verso una fraternità. È ovvio, se si vive in superficie sapremo solo alzare muri che dividono, oppongono e non salvano. Terzo punto, dialogo transdisciplinare. L'espressione di Papa Francesco, ossia che le religioni non si contraddicono ma si dicono a vicenda, può ispirare anche il dialogo tra le diverse discipline scientifiche. Scusate, ma gli scienziati ci dicono che siamo tutti fragili, anche la voce. È la transdisciplinarietà, ossia una modalità di condurre la ricerca che inizia ascoltando i diversi saperi scientifici che hanno un forte impatto sul nostro modo di pensare il mondo e il cosmo. Ci rendiamo conto di quanto le nostre categorie di pensiero siano influenzate da quello che le scienze ci fanno comprendere della realtà. Un'articolazione delle differenze che non si realizza senza fatica e pazienza. Questo dialogo comporta la capacità di tradurre, cioè di compiere un procedimento che richiede di conoscere e comprendere l'altro e il suo linguaggio per poterlo interpretare all'interno del proprio, sapendo che la riformulazione in un idioma diverso potrà essere al massimo equivalente, ma non identica. Ecco perché non abbiamo bisogno solo di congressi, ma di convivenze, di dialogo effettivo tra scienziati, tra credenti, tra umanisti, tra giuristi, tra saperi, in quella università scienziarum che ospitava tutte le scienze e che produsse quel rinascimento straordinario che a Roma ha avuto una manifestazione straordinaria. Ecco perché dobbiamo riconoscerci gli uni gli altri. La dinamica della traduzione è quindi emblematica di ogni dialogo, che può ottenere un'intesa o addirittura una riconciliazione solo a patto di lasciare la presa sull'assolutezza del proprio punto di vista, accettando di perdere qualcosa. Siamo tutti fragili, tutti relativi. Occorre quindi uno sforzo di mediazione tra il significato originale e il contesto del testo tradotto. Questo processo implica un inevitabile tradimento in cui qualcosa si perde o si altera nel passaggio, ma è anche arricchente, in quanto permette un dialogo tra culture e idee diverse. La traduzione è quindi un processo dinamico e complesso, attraverso il quale idee, oggetti e attori, umani e non umani, vengono reinterpretati e trasformati attraverso le loro interazioni in una rete. La traduzione non si riduce all'ambito linguistico, ma riguarda il modo in cui gli attori negoziano, modificano e stabilizzano le loro relazioni, i loro ruoli in una rete. Sono decisive anche le affezioni nel dialogo. Sono implicati processi di mediazione, delega e trasformazione in cui ogni attore contribuisce alla definizione e alla ridefinizione degli altri. Conduce alla riformulazione delle domande in un modo nuovo. Ad esempio, le teorie dell'evoluzione ci fanno porre in modo nuovo le domande sulla creazione, come ancor prima Galileo aveva costretto i teologi a ripensare quale fosse l'intento fondamentale della rivelazione biblica, sfrondandone dei significati che erano concrezioni secondarie. Anche oggi non è solo questione di avvalersi dei contenuti conoscitivi che le scienze ci offrono, ma di renderci conto del nuovo contesto in cui ci collocano. La storia dell'universo e l'evoluzione della specie ci sollecitano a risituare l'interpretazione anche del cristianesimo nello spazio aperto da una visione della natura e della vita umana che sono l'esito di un lungo processo evolutivo. E concludo. Sta a noi perciò lavorare alla costruzione di un'arca comune che ci salvi dal diluvio. Un'arca, un luogo ordinato, secondo la parola di Dio, che Noè ha ascoltato attentamente per realizzarla, in modo da custodire la logica della creazione. Ne è elemento indispensabile la dominazione del proprio dominio che è tipico di Elohim nel primo racconto della creazione, una mitezza capace di trasmettersi e di coinvolgere anche gli animali, grazie al limite che pone a se stessa. L'arca diviene il simbolo di uno spazio in cui il progetto di vita di Dio può navigare attraverso la morte e la distruzione violenta verso un nuovo inizio. Certo, la convivenza non è scontata e la fatica dell'armonizzazione delle differenze è molto esigente. Per rimanere nella nostra immagine, la vita nell'arca non è semplice, come anche il nuovo inizio, segnato da una seconda emersione della terraferma, che ci è raccontata dall'episodio biblico come una specie di nuova creazione ed è molto più lunga di quella descritta nel primo capitolo della Genesi. 40 giorni e diverse settimane di esplorazione che mostrano Noè come un uomo della pazienza e della speranza, una speranza che non è sinonimo di rassegnazione o di rinuncia, ma di attesa operosa ed esplorativa, con l'aiuto di tutti i mezzi disponibili. Aveva corvi e colombe, non aveva droni a quel tempo, Noè, ma esplorò comunque, resistendo nella durata, affidandosi alla promessa di una parola che ritiene degna di fede e che comporta una decisione di poter accedere alla realtà di quanto annuncia. È in questo spirito noaico che vogliamo compiere i nostri 3 giorni qui, a Roma. L'alta età di Noè 600 anni, era un grande anziano Noè, quelli che la cultura contemporanea scarta. Il Padre Eterno lo prese, 600 anni. Questa età alta ci suggerisce non solo la nostra responsabilità di anziani, compresa la mia, che fra 2 mesi farò 80 anni, ma forse esprime ancor più l'urgenza di moltiplicare sia i soggetti che le arche. Dobbiamo costruirne 1, 100, 1000 arche a disposizione dei tanti naufraghi di questo mondo contemporaneo. Oggi stare tutti sulla stessa barca vuol dire solamente immaginare tante barche le une legate alle altre per salvare la navigazione di tanti. Le barche dovranno fare la spola fra le rive, tenendo a riparo le creature destinate a portare e a far crescere la vita sulla terra. Dovranno diventare, insomma, una dotazione permanente e dovranno essere attrezzate per custodire ogni vita in pericolo, per consentire ad ogni vita di superare l'emergenza e ritornare ad abitare la terra con i fiori, i frutti e le nuove generazioni che la faranno rivivere. Insomma, non una sola, ma tante barche che riflettono sulla terra quell'arcobaleno di colori che indica una irriducibile unità plurale. Il concetto di cittadinanza che appartiene a tutti. Io vorrei alzare la voce contro coloro che usurpano il diritto di cittadinanza ai loro vicini, come coloro che pensano che l'ordo amoris inizi da sé, dal suo vicino, dal suo provicino e gli altri non le riguarda. Il Vangelo ci dice l'opposto. L'ordo amoris inizia dall'uomo mezzo morto che abbiamo scartato. Bene, questa è la cittadinanza. Ogni uomo, ogni donna ha diritto ad essere cittadino della terra. La cittadinanza è un concetto umanistico, non robotico, non predatorio. È un titolo di convivenza e di fraternità che si rende accessibile alla volontà etica di onorare la dignità umana. Non una merce che si compra e si vende in base alla potenza di interessi speculativi che ne sfruttano la rendita materiale senza restituzione. Noi non siamo chiamati a vivere la fraternità per essere rieletti. Gesù non fu fatto imperatore, fu crocifisso e morì chiedendo perdono per quelli che lo stavano crocifiggendo. Che differenza dallo stile mercantile che oggi sembra regnare in questo nostro mondo. Ben altra è l'umanità e la terra che noi sogniamo. Sì, quella della vera uguaglianza, quella della vera libertà, quella della vera fraternità. Ecco perché l'umanesimo della religione, che deve imporre a tutte le formazioni storiche dell'apertura alla trascendenza salvifica del divino, l'etica radicale dell'amore del prossimo come punto di verifica inderogabile, deve ridiventare un tema di incoraggiamento per l'esperienza spirituale di una passione condivisa. Il cristianesimo espone nel modo più diretto e trasparente il tema di questa saldatura che fissa un punto inderogabile di verifica per l'accettabilità della religione. Cito la prima lettera di Giovanni. Se uno dicesse io amo Dio e odiasse il suo fratello, è un mentitore. Chi non ama il proprio fratello che vede non può amare Dio che non vede. Questo è il comandamento che abbiamo da Lui. Chi ama Dio, ami anche il suo fratello. Grazie.
Bene, grazie al Presidente Monsignor Paglia. Come sempre queste lezioni proprio introduttive sono ampie, stimolanti, provocatorie, pacate, ma soprattutto appassionate. No, pacate, dal mio punto di vista molto equilibrata la visione che ci ha proposto.
Non dimentichiamo che c'è anche il fuoco di paglia, però non importa.
È anche ironico come sempre, quindi grazie. E quindi in questa prima sessione ci mettiamo subito ad applicare quanto ci chiede il Presidente di ascoltare la scienza. In questa prima sessione dedicata alla crisi e ai cambiamenti di paradigma, avremo 3 veramente illustri scienziati che ci aiuteranno nella visione del mondo. Giustamente diceva il Presidente che la nostra visione del mondo è influenzata dalla scienza. Noi abbiamo una visione prospettica perché siamo esseri finiti e quindi abbiamo una visione in una certa prospettiva e quindi la scienza ci aiuta ad andare oltre questa prospettiva, a capire che cos'è il mondo, e queste relazioni saranno scientifiche ma anche al tempo stesso filosofiche, ci apriranno delle prospettive di grandissimo interesse sulla nostra conoscenza, dove è arrivata, dove sta arrivando la nostra conoscenza e anche i limiti della nostra conoscenza. Prima di dare la parola al nostro primo relatore, vi voglio dire che alla fine delle 3 relazioni, quindi alla fine, alle ore 17 circa, ci sarà la discussione. È possibile subito dopo la relazione già scrivere eventuali domande, sono accettate solo domande con la compilazione di questi foglietti che troverete nelle cartelline, scritti maiuscolo, altrimenti sono illeggibili, dire anche a chi si rivolgono queste domande. È possibile scrivere solo in italiano, in inglese, in francese oppure spagnolo, nessun'altra lingua, e scriverete le domande che verranno raccolte dalle signorine che sono qui presenti e che ce le porteranno. E anche online, è vero, scusate, il cancelliere è sempre precisissimo, anche chi è online potrà tramite le chat mandare le domande che ci verranno raccolte e ci verranno date, quindi così che la discussione potrà veramente essere partecipata da tutti coloro che vorranno partecipare alla discussione. Bene, grazie, e diamo subito la parola, ho l'onore di presentare indegnamente, ma insomma, questo scienziato importantissimo, il professor Guido Tonelli. E il professor Tonelli è professore emerito di fisica all'Università di Pisa, è laureato in fisica all'Università di Pisa e dal 2007 al 2012 ha lavorato al CERN, primo Scientific Associate e poi Senior Staff Scientist. Il suo principale contributo tra i molti contributi scientifici è stata la scoperta dei bosoni di Higgs e ha ricevuto moltissimi riconoscimenti e premi internazionali, tra cui ne ricordiamo 2, lo speciale premio per la fisica fondamentale nel 2012 e il premio Enrico Fermi nel 2013. A lei la parola, grazie.
Grazie, buon pomeriggio a tutti. I will go in English through the presentation, volevo ringraziare il Monsignor Paglia e gli organizzatori del convegno per avermi invitato. It's an honor and a privilege to be here, so let's go. I will talk about science and the vision of the world we live in, and the first slide is just Photoshop, in which you have a sort of eye. What you see there is our experiment. We call it our baby, although it weighs 14,000 tons, and it is 4 stories high, so 16 meters. Is the detector that we use to detect collisions at LHC, at CERN. And overimposed is one of these collisions, is one of those used to claim the discovery of the Higgs boson. So what you see there is possible candidate for Higgs boson. And there is, I try to use the four figures just to give you the hint that through fundamental science, we develop technologies, basically technology that can be used for health issues on the right, or for communication, or to build robots, or to go through space. This brings me to the first slide, which is basically, we go back 100 years, in 1925, basically, and we see that thanks to the work of a handful of people, maybe another 20 on top of those, you might recognize all of them, a new vision of the world was developed, basically, roughly speaking, 100 years ago. It's a new vision of matter, and today that we are far enough to realize that from this vision of matter, at the beginning, it appeared to be a useless step. Nobody was really aware of what would have happened in the next few decades. Today, we know that all technologies that we use today comes from there. If I would stop quantum mechanics today from the entire world will be basically blocked. There is no hospital that will continue to work, no company, no communication, no car, no ship, nothing, basically. Everything that we use today is based on a deeper understanding of the behavior of matter at the microscopic level that was developed by these people. But this is not the thing that I consider the most important one. For me, the most important issue is the fact that the new vision of the world produces basically a change in our culture. The culture means the way in which we organize ourselves, the way in which we organize our family, or our cities, or our states. There was nothing that was unchanged. And the proof of it, if you take a look, I listed some of the names, representing different areas of culture, from theater to music to figurative art or for literature. And you see, if I name Strindberg, Pirandello, Schoenberg, Berio, Kokoschka, Fontana, Joyce, Musil, Freud, and clearly there is a connection, a clear connection with a different vision of matter and the universe that was developed at the beginning of the century. That means that you change everything, including yourself. If you look inside yourself now, or you looked at in the 19th century, it was completely different. Your family, your friends, your love, your sexual activity is completely different. Once culture changes, everything changes. The way in which humankind organizes itself in different relationships, from the private sector to the society level, changes in depth. Science basically is the basement on which the vision of the world is built, and is a sort of pillar. Whenever there is a change in the paradigms, initially there is nothing happening. It appears that it's a new discovery, who cares? But if you look at what happens later at the level of decades, you discover that sooner or later this change in the vision of matter and the universe propagates in the life of everybody, not only through the technology, but also a different attitude, a different cultural attitude. But since science continues to produce new results, we have to know this new result. The results of today means the last 30 years, will shape the future of our kids, of our sons or grandchildren. The rest of the century will be shaped by what we know today coming from the recent discoveries. So my mission here is to make you aware of some of those, just to be better prepared to face the challenges of the rest of the century. In some sense, modern science continues to provide answer to an ancestral needs, the same need that drove our ancestors to to describe in these dark caves their vision of the world. Today we know that those is a very ancient activity, very old activity, maybe tens of thousands of years ago. This is the beginning of the story. And this story that continues, this is Elena. Elena now is my granddaughter. She's 16, but this is a picture I took of her when she was 4. And the reason of this picture is that when she was 4, we were in a beautiful summer night in Sardinia, looking at the stars, and she asked me the old question, what is this? And what is the story of what we see here? And what will happen in the future? So this is the question that each one of you has inside you, is a question that the baby humankind, since the very beginning, discussed, produced theory, produced ideas, produced myths, produced scientific options. So modern science basically is trying to give an answer to the same question. Very simple issue, very simple goal. So, and we have 2 roads, basically, two basic roads. One is the road that I'm following. I'm a particle physicist. That means that we use super microscopes. Accelerator particles are tools that very complex, very sophisticated, but basically in which we try to produce in laboratory, under controlled conditions, the microscopic particles that populated the baby universe. So basically, we try to understand the origin of the universe, reproducing in laboratories, not the Big Bang. Don't listen to this popular explanation. We are, luckily enough, we are not able to produce the Big Bang, because otherwise somebody would use it for questionable goals. No, we try to produce and study the behavior and the characteristics of elementary particles, very small particles that have disappeared today in the universe in which we live. I cannot go to the market and say, give me 1 kilogram of Higgs boson, because the Higgs boson disappeared in its independent state in the very first instance of the universe. The universe is very cold. Today is too cold to allow these particles to live freely. This is why we need to heat dramatically a small amount of matter, and in this extremely high temperature volume, we have particles that can flourish again. They live a tiny fraction of a second, but enough for us to measure their characteristics. And the other road is completely the opposite. We study the smallest particle, the most incredibly small particles we can imagine. The other part of the team is the astrophysicists or the astronomers. They study the largest possible structure. They study stars, galaxies, or the entire universe. And they use super telescopes. That means that they use devices that allow them to see objects which are very far. Looking very far, that means that you look very back in time, because light has a speed which is high but not infinite. That means that if you look at an object which is 1 billion years away, far away, you look at it as it was 1 billion years ago. That means that you can observe the universe, the evolution of the universe, just looking at the possibly farthest object you can. Now, this is what is happening. Also, in their case, we have very complex devices. Here you see a picture describing LHC. It's a 27-kilometer tunnel, a lot of complex infrastructure, and the same is true for modern super telescopes. So super telescopes or super microscopes, they require extremely complex objects. And what do we know of the material universe surrounding us? This is the picture that describes basically a century of exploration. And we know that the object comes from a very tiny element that we call a singularity at the beginning. It is a very old object, 13.8 billion years. It is expanding still, and recently I've discovered that the velocity, the speed of expansion is increasing. I would highlight here basically three things which are relatively new, new in the sense that would have been astonishing for the big scientists of the beginning of the century. They are not really new to people that knows the story, but things that we have discovered in the last few decades on which I think we should concentrate our attention. This is, for example, a possible view of the Milky Way, our home, our galaxy. Is an object which is 100,000 light years, so an extremely large object. But it is funny to realize that now you see another scale. This is a possible picture of a fraction of the universe. It's a survey in which this dot is a galaxy. A galaxy is a cluster of 100, maybe 200 billions of stars, including stars that have solar systems, so a huge amount of celestial bodies. So our galaxy, which appears to be so large, now is a tiny dot there. This gives you the feeling of how stupid is any form of egoism or narcissism, or that Vincenzo was alluding before. No, so we are there. We are this one. No, we are a planet orbiting around a star which sits at 26,000 light years from the center of a galaxy, which is 1 over, we estimate, 100, 200 billions of galaxies occupying the universe. Remember Albert Einstein, that was the most brilliant mind ever. 100 years ago, he was thinking our universe is just our galaxy. He, like all the other scientists of the period, they were not aware that our galaxy is a tiny element of a huge family of hundreds of billions of other galaxies. So this gives us the dimensions. Now, what are we, and with respect to this scenario? First, food for thought. There is a myriad of worlds surrounding us, and another thing we have discovered recently, and then when I was young, planets were considered extremely rare objects. Now we consider that planets are orbiting around most of the stars. So whenever you take a look to a star in the sky, consider that there will be very likely planets orbiting around. That also means that since the number is impressive, we should be prepare ourselves to a period that I think will be not too far away, in which scientists will start discussing the possibility that in one of those exoplanets, which means planets orbiting around the stars which are not our sun, there will be conditions that might allude to the presence of life based on carbon cycle. This will happen very likely quite soon. So again, another change of paradigm that will be probably within a few decades, maybe sooner, I don't know. And second thing, the world of the large distances is the kingdom of general relativity. So Albert Einstein found the right tool to describe this world. He described gravity in a completely different way. Gravity is a geometrical issue, basically. No? At the end of the story, there are basically two ingredients. If you want to make a universe at home, I give you the receipt, which is easy. Mix together two simple ingredients. I cannot give you the ingredients, but at least on paper, you can claim, I know how to do a universe. You mix together mass energy, stars, dust, whatever, and space-time. That's it. A nice mixture. I cannot guarantee that your universe will be nice as the one in which we live, but scientifically, any mixture of mass energy and space-time will be a universe. You cannot define differently. And this is a picture representing the story, you know, our Earth, the forms, the space-time, and in the moon, see the deformation and orbits around. So it's the standard way of describing gravitation. A thing I want to highlight, this is new the acknowledgement of this fact, although we have not yet digested this concept, because we are still prisoner of prejudice. No? The prejudice that the space-time is a sort of scenario which has no impact on what is happening inside. No? This is basically, we are still son and daughter of the absolute time and space of Newton and Immanuel Kant. No? So we have not yet adjusted our mentality to what science has discovered since decades. That space and time, space-time, is the same substance and is a material substance. It's not a concept. It's a material substance. And this is difficult to digest. No? But you need to be aware that scientists have proven that once you have an object that can be deformed, you cannot deform the concept. You can have a concept which contains energy. You cannot have a concept that distributes energy through fluctuations, waves. No? All this can be done by space-time. It is really the fact that we had this prejudice because it is an object so rigid, no, which is difficult to deform. Only very heavy object can deform it. So I tried to deform the space-time. I didn't succeed with my fist, right? Because it's extremely rigid. The sun can deform the space-time. But if you want to produce waves in the space-time, not even the sun is able to produce waves in the space-time. So to produce this vibration, no? That's easy for me with this piece of wood. If you want to produce waves in the space-time, you need black holes or neutron stars colliding together, something extremely powerful, much more powerful than the sun, because the space-time is extremely rigid. It's one of the most rigid substances we can imagine, but is a material substance. Is a material substance. And the funny thing is that basically, you see the gravitational waves, the things that I was alluding to, discovered in 2016, 100 years after the initial idea coming again from Einstein, from the general relativity. But just to give you a hint, Einstein himself was not convinced that gravitational waves would exist, no? Because he considered it a curiosity. No? A curiosity. He changed his vision several times, but just to give you an idea that the prejudice is so high that even the inventor of the general relativity was skeptical on the possibility that space-time could vibrate. And with great surprise to Einstein himself, it was soon evident that also matter, energy, and space-time were not there since ever. Again, another prejudice. No? Albert Einstein was Aristotelic in some sense. He considered the universe static, and actually, to make it static, introduced on purpose the lambda constant, the cosmological constant, because in a universe in which only gravity would have been present, this would have collapsed immediately. No? But since the universe is there, he said, I have to do something. And he put by hand, artificially, a positive constant that would keep the gravity under control. That means he wanted a static universe, an Aristotelic universe, okay? And then he reacted to the idea that was coming from his own equations, no? Because when Georges Lemaitre, that was a young priest, an excellent scientist, came to him and said, look, master, I found a solution depending upon time of your equations. And I'm making some mistakes. Take a look. And he took a look, and he didn't discover any mistake. And he said, your calculations are right, but the conclusion is incredible, is abominable. I cannot believe to the conclusion. The conclusion was that there was an origin of the universe. There was a time in which there was no space-time. No, clearly difficult to digest, no, for scientists that were used to believe that the universe was there since ever. And it's the story of Alexander Friedman, of George Lemaitre and others, Hubble, Now we know that the universe, the observation universe was expanding, and then you have this movie that you can basically project backward, and you see that there is a moment in which the universe that is expanding is a point-like object. Lemaitre called it the primordial atom, so it's the beginning of the Big Bang. The entire century was full of confirmation of this theory. Now, the initial skepticism was easily overcome later on. There were people really, Fred Hoyle was one of those, fighting up to the end, like the last Japanese against the Big Bang theory. No? He was not convinced at all, but at the end of the day, the accumulation of data was such that even the most skeptical decided to surrender. But this was not the most astonishing discovery of in my view, my personal perspective. I think the thing that was really the most astonishing one was to realize that the overall energy of the universe is zero. And this happened 30 years ago, 25 years ago, in this period. No? It was due to it was possible thanks to precision measurements of astrophysical parameters. No? Things that was not possible in the 50s or in the 60s. We had to wait up to basically close to the end of the century, because also only in that moment it was possible to measure with high precision the characteristic of the universe. To use it, examine the universe as we examine an atom. No? Examine the universe as a physical system, no? Measuring with excellent quality the property. Basically, in this period, we discover that the universe has energy, which is zero, total charge, zero. For each positive charge, we found negative charge elsewhere. The total angular momentum is zero. That means every galaxy turning around in a certain preferred direction, there is another one turning around in the opposite direction. There is no preferred direction of orbital motion. Conclusion, the universe quantum numbers, you see, we study a physical object, an atom, and we describe the quantum numbers of the atom. We describe the quantum numbers of the universe, 0, 0, 0. So our universe has the same quantum numbers of the void. This was the most astonishing discovery in the last 30 years. So we can today call back to Hesiod. At the beginning was the void, no? Because Hesiod called it chaos, but chaos in Greece is not the disorder system that we use to translate. Chaos is a word that keeps an echo of kaino or kasko, chasma, all means something like an open wide or a vortex or what we call today vacuum, the void. The Planck universe, the universe that we are able to describe through the satellite, one of the most recent one was the Planck satellite, allows us to measure the cosmic microwave background with such a precision, measuring the anisotropies of these distributions and measuring the size of this distribution, we can collect quantitatively information on the quality and characteristics of the universe. And basically, we discover that the universe is still today a vacuum state. And immediately we realize, but then the origin of the universe is a transformation of the vacuum states. So, it's a vacuum state that becomes a universe that is still a vacuum state. So in some sense, it's like having understood what happened really in the Big Bang. The Big Bang was not something happening from scratch. No, it's a transformation of a system in a system which is identical to the first one with a different evolution. We know how it could happen because the void is not nothing. The void is a physical, is a material state again. It's a material system that follows the laws of physics, saying that the void has zero energy. That means cannot have zero energy, meaning that whenever you measure the energy of the void, you measure 0, 0, 0, 0. This is forbidden by the laws of physics, by the Heisenberg principle. So each state should follow the quantum mechanics laws. And in this particular case, that means that there are fluctuations. So the vacuum state is full of fluctuation. There are vacuum fluctuations that are allowed, providing they follow the Heisenberg principle. In some sense, the void contains everything. No? It might be seen as a source, inexorable source of matter and antimatter, no? Because we know that if we have electrons and positrons, or protons and antiprotons, you can have a vacuum state. You can extract from the vacuum matter, particle, antiparticle. It's forbidden to extract only one, positive or negative, because you violate the request that the vacuum should be zero charge. But you can extract in pair. And the extraction in pair, or you provide energy to the vacuum, or it happens spontaneously. If it happens spontaneously, it lasts for a small amount of time. The larger is the energy which is extracted from the vacuum, the smaller is the amount of time for which this is allowed. But if you have a system which has zero energy, remember this, if it has zero energy, then can last forever. So you are limited. You have limits in which if you have energy, positive energy, but if you have overall energy zero, this extraction can last forever, can last for 13.8 billion years and over. So basically, this is what we think it will happen, because the initial phase, which contains still many unknowns, we imagine a strange material that we call inflaton, which is extracted from the vacuum. It occupies a small bubble, a small fluctuation. So the small fluctuation of the void are able to, let's say, be impregnated by something coming from the vacuum. In the case of the inflaton, it is neutral. That means there is no issue of charge. And if it happens that the positive energy of the mass of this particle is balanced by the negative energy of the space-time, then you have zero energy element. Remember, space-time, which is bent by matter or by energy due to general relativity, contains negative energy. So you have positive energy because of the particle, negative energy because the space-time with the particle inside is bent, total energy is zero. This bubble can expand, continue, produce a universe for billions of years. There is now no physics law forbidding this. So basically, what we think today is that a universe can be born for free, without spending energy. Since the total energy of the system is zero, the system can last forever. In growing, the bubble extracts from the void additional inflatons, and the push to expansion grows exponentially. Basically, today, while we have measured that the total energy of the universe is zero, the universe is flat, it is close to the critical mass. So all this information gives us hints on what could have happened at the beginning of the universe. And here you see, for example, the vision that we have, what could be our universe at the end of this inflation era. We are talking of 10 to the minus 32 seconds after the Big Bang, imagine it. So dimension is like this, like a soccer ball. And it's a universe in which you have already all particles, all matter, all energy, the entire universe. But it is, in some sense, it is a perfect universe, but basically useless. This universe would never produce this auditorium or the Sistine Chapel or the stars or the galaxy. Would have been a perfectly symmetric but completely useless universe. And the reason of this we have understood recently, because we have discovered this particle that is the Higgs boson, that basically froze 10 to the minus 11 seconds after the Big Bang, and produced an invisible field occupying the entire universe from there till now. So today, the entire universe is filled up with this field that we call boson field or electroweak vacuum, which has an incredible importance in the subsequent evolution. Basically, the electroweak vacuum interacts with all the particles that are massless, and with the different strength of the interaction, they acquire different properties, different mass. And this mechanism is vital to produce aggregation of matter. If the universe would have been full of massless particles, there will be no stars, no dust, no planets, no human being, nothing. It's impossible for massless particles to aggregate, to form material structures. While after the interaction, they start differentiating. That means that you have electrons acquiring a small mass, or quarks, light quarks, that can group together to form a few quarks and the gluons. They form a protons, and around you have an electron. You have an atom. You start having material shapes, material forms that will give origin to the universe as we know today. So basically, we have understood through the work of these two guys, Francois, Peter, Robert Braut, unfortunately died a year before, that got the Nobel Prize for Physics, that we have, let's say, something in our universe which has produced a tiny, delicate mechanism that was extremely important to produce matter in the form of condensed matter, in form of dust, in form of stars, in form of planets, in form of rocks, down, up to us. Another surprise, once you have discovered the importance of this mechanism, the electroweak vacuum, the second question we asked ourselves is this mechanism stable? Is this equilibrium will last forever? Or there might be surprise. And we study this situation. Is a sort of diagram of phase in which you have the green part, which is stability. The red is instability, is a universe that cannot survive. And with our surprise, you see our universe where it is sitting in this yellow, very tiny yellow part, which is that the electroweak vacuum is stable, but is not hyperstable, could be destroyed for some reasons. And if would be destroyed, the entire, you have used as a title, the end of the world. Now I can give you the end of the universe. No? So if this would happen for some catastrophic phenomena in some part of the universe, the entire universe will come back to this previous state in which there are still particles, but there is nothing aggregated, nothing really, nothing can survive, no star, no dust, nothing. An immense structure, completely useless, in which there is nothing really can be recognized. In my view, the knowledge, being aware of this, being aware of the mechanism that bring the universe to have an evolution in which we have been basically somehow fruit of this evolution, but before us, our planet or the solar system or the stars, etc., basically gives you a couple of hints of something dramatically changing our vision of the world. Protons, neutrons, electrons, photons, and gluons form the backbone of each individual structure. No? A slight perturbation of the Higgs boson would change dramatically all this. Nothing will be able to survive to a slight perturbation of this. So remember, just a second, to the issue of fragility, that also Monsignor Paglia alluded at the beginning. For millennia, we have considered our own fragility as a kind of peculiarity, considering the rest, our planets, or the moon, or the sun, or the entire universe, material forms so huge to be eternal, And to overcome this issue of fragility, we have built, by the way, some of the best artifacts, no? Because at the end of the day, art or philosophy or religion or science are just way in which we try to produce something that will last beyond our own individual existence. No? So we try to look for immortality through the let's say, basic what we produce in terms of thoughts or in terms of beautiful art, piece of art. So today science tells you, it tells us, tells everybody that every single piece of matter is fragile. Even the ones that we believed will be so immense, so powerful, no, there is an intrinsic fragility. And in some sense, there is something precious. Not only the life of human beings or the animals or the vegetable, let's say the trees, there is something really special. No? But even a piece of dust is special, is precious. Even a piece of mood is precious because it's something unusual in the universe. Only a very tiny amount of matter and the universe is organized in a form that is a material form. No? So, in some sense, this vision brings us to be more careful, not only with respect to ourselves and to the world surrounding us, but each individual piece of matter should deserve our care, our attention. I conclude remembering that the story of science continues, the story of the search for scientific research continues. Is a challenge that continues. Today we are asking, basically, what is the origin of the inflation? What is this particle producing this inflation? What is the origin of dark matter keeping together the galaxy? What is the origin of dark energy that accelerates everything? So some more will come, maybe very soon or in the next generation of scientists. Thank you very much.
Grazie professor Tonelli. Accettiamo la intrinseca fragilità di tutto l'universo. Come dice l'Apocalisse, anche il sole si spegnerà e tutto si consumerà. E invito la professoressa Sarah Johnson al podio. I remember, please. You have the same time that was scheduled. Sorry, noi spostiamo il coffee break di 15-20 minuti. Sarà un coffee break più corto. Tutto è fragile, anche il coffee è fragile. Please.
So we introduce Professor Sarah Johnson. The title of the lecture will be Life as We Don't Know It. Professor Sarah Johnson is Professor of Planetary Science at the Department of Biology and Science Technology and International Affairs Program at Georgetown University in Washington, D.C. And she focuses her research above all on the biosignature within planetary environments. Her lab is involved in the implementation of planetary exploration, analyzing data from current spacecraft, as well as devising new technique for future missions. She is visiting scientist with the Planetary Environment Lab at NASA's Goddard Space Flight Center. Thank you.
Thank you. And I'm so honored to be here. And I thought today that I would talk about how it is that we build a body of understanding, how we come to know what it is we know, and especially how we contend with the truly alien, primarily as seen through the lens of my research as a planetary scientist. So let's begin. For millennia, most of the planets appeared just like this, a mere point of light in the night. But even the ancients knew that there was something special about these 5 points of light, the wanderers. And these wanderers, they moved separately from the backdrop of the fixed stars. And one of them, this one here, Mars, had a very distinct color. It was red, and it blazed sometimes as bright as the 3rd brightest object in the night sky. And it wasn't just its color that was so perplexing, it was also its motion. So these wanderers on Mars would move east against the backdrop of the fixed stars, but every couple of years, for several weeks, it would backpedal against the zodiac and move westward, and then it would resume its course. And from this, Plato even concluded that the planets must have free will, because what else could these retrograde motions be expressions of? And it wasn't until the dawn of the space age, really at that point in time, we knew so very little about what Mars was. Some of it was right. It has a remarkably similar length of day. It has polar caps, but most of it was just wild speculation with so few data to cabin our inquiry or limit our imagination. Mars became all sorts of things, often a reflection of what we most wanted to find there. But when the first mission to Mars went in 1965, it was the first time that humanity ever saw the face of another planet. And that moment was incredibly disappointing, because these were the sorts of images that were returned from the Mariner 4 spacecraft. This world that was covered with craters. And those craters meant that Mars was like the lifeless moon, that Mars had no oceans, no waxing and waning of seasons, no forest or tundra-like growth proceeding across the planet's surface. There was no resurfacing of any kind that would make it a world like our own. And the New York Times even declared that Mars was probably a dead planet. But fortunately, we returned with lots of other missions, and so many times we were led down blind alleys with twists and turns, and this was one of them. Everyone thought that Mars was flat. It was this small planet. It had much less heat of accretion. And how could such a small planet so far from the sun have enough vigorous geological activity to build giant landforms? But when the Mariner 9 mission went in 1971, this image was one of the first returned as a dust storm began to settle. And these 3 peaks are giant volcanic calderas. And everyone was so surprised. But it turns out Mars has extraordinary relief. These mountains were not the only one. There was a place called Nix Olympia, which had to be renamed Olympus Mons because it was the size of Arizona, and its escarpment alone was taller than Mount Everest. And this mission continued, and as the dust cleared, we saw that, yes, there were craters on Mars, but there were also river valleys that had been carved in the ancient past, meaning that Mars had a very, very different sort of past, a warm and wet beginning. In 1976, when the Viking landers touched down on the surface of Mars, the first image they took was of one of the foot pedals of the lander, just to make sure the ground was solid. But this was the second image, and you see it has a blue sky, but Mars doesn't have a blue sky. Mars has a sky that's more like the color of butterscotch, but the little diodes on the cameras were also sensitive to infrared light, so they had to be calibrated, and the engineers calibrated them wrong when they first released this to the public. The most exciting thing about that mission, what was billed by many as the greatest experiment in the history of modern science, were the life detection instruments that were aboard. And a very strange thing happened. Some of the signals came back, but almost too fast, almost as if there was some sort of chemical oxidation going on instead of the detection of life that they were meant to find. And the kicker was that a chemistry instrument, a gas chromatograph mass spectrometer, found no evidence of organic molecules, the carbon-based molecules that are the building blocks of life as we know it. And this also was incredibly perplexing because even that lifeless moon has some of those organic molecules. They can be created abiotically. They can rain down from comets and meteorites, but there were none here on Mars. That is until 2008 when we sent the Phoenix lander, and one of its instruments, which was actually calibrated to detect nitrate, found this overwhelming signal from this crazy salt named perchlorate, which was basically dry cleaning the samples. When you heat this salt along with those molecules, they evanesce, they disappear. And then we realized why we hadn't seen that signal whatsoever. And the twists and turns continued. I remember this well because this mission, the Opportunity rover, was the very first one I had the opportunity to work on. I was a first-year graduate student when it touched down in 2004. And this was the surface it touched down on, covered with these teeny ball-bearing-sized, round concrete conjules. We called them blueberries. These hematite, tiny balls. It was the sort of surface that Fred Flintstone would have slipped on had he found himself at this place. And it turns out these little concretions can only form in the presence of water. And we also found all sorts of evidence there that the water at Meridiani was incredibly acidic. It was the kind of water that had the pH of battery acid, not the kind of water that's very, very good for life to form in. But then let's go forward another decade, and when we land with the Curiosity rover, which I'm also working on, we found these soft gray mudstones. And this was formed in the kind of water that if you had been standing on the planet 4 billion years ago, you probably could have drank with a neutral pH, a kind of sweet water. And there have been so many times that we've thought we understood the geochemistry or the geophysics of this planet. And you can see it's a world that looks so incredibly familiar. It's the kind of place that you could scrape your knees walking around. But it's every bit as complex and enigmatic as our own planet. And it surprises us. And I'm going to spend the rest of the talk discussing how I think it also may surprise us when it comes to the search for life. So as astrobiologists, we often think about the search for life by starting with what we know. We look for particular classes of molecules and isotopes, molecular weight patterns within fatty acids and other types of lipids. We look for structures and textures. We look for biogenic minerals, the sort of well-established and widely accepted features associated with terrestrial life. And we've gotten really good at doing this. Like, we can use them out in extreme environments around our own planet where there's very little life to detect in the first place. We can use them going back into ancient history within our own rock record, even billions of years. And it's great to start with what we know. If you were to say, lose your keys on a dark night, why not begin by looking underneath the streetlight? We're starting from what we understand. It's easier to interpret the information. We may have really rich in information, those particular signals we see. And we have a strong understanding of taphonomy, or the effects of time. Kind of like paleontologists don't go off into the Rocky Mountains to find a dinosaur. They look for dinosaur bones. It's the same with molecular fossils. We may lose a few functional groups like fingers and toes, but we can still find those backbones of those molecules, again, billions of years into our own history, and we can use those to reconstruct life and what the environment was like. And Mars is also so similar to the Earth, especially around the time that life was getting started. These worlds had very similar surface conditions, very similar atmospheres. And there's also a chance that life on Mars and life on Earth could be ancestrally related, that we could have just caught life from the next planet over. Colleagues of mine have looked inside meteorites that have come from Mars and shown that some of them have not been heated above sterilization temperatures. And models suggest that some could have arrived on very fast trajectories. And it turns out that the billion tons of rocks that were exchanged between Earth and Mars early in their histories, more of those came from Mars to Earth because of the gravitational well of the sun. So if we do share a common origin, it's more likely that we're all Martians than Earthlings. But beyond this, I think it's very important to be aware of the limits of analogy. And I mean that in two ways. One is that we're on a spectrum of even understanding what biology is. And when we designed those life detection experiments back in 1976, one of them, which was nicknamed the chicken soup experiment, designed by a man named Vance Oyama, that experiment basically took a nutrient-rich broth, added some soil, and looked for signs of growth. And this was before we realized that the vast majority of the simple microbial life on our planet would not grow in a laboratory, would not grow in a nutrient-rich broth on a petri dish or something like that. And we didn't know that before the advent of genomics, before we could sequence all of the things that didn't happen to grow in our laboratories. And I would argue that if we were to design those experiments today, that we would design them very differently. But I also mean the limits of analogy in terms of things that might even be beyond the confines of our current imagination. So I wanted to really emphasize this because we are not only searching for life on Mars, our near neighbor. We are beginning to search for life in the far reaches of the solar system. For instance, this is the moon Europa, a moon of Jupiter, where underneath this ice surface, this what looks like a bloodshot eyeball, you have a liquid water ocean that we think has existed as long as the Jovian system has existed. And we are beginning to send missions to this world to look for possibilities for life. We're also thinking about Enceladus, a tiny little moon of Jupiter, only 1/7 the size of our moon. Enceladus has these cryovolcanoes, over 100 of them, and 500 pounds of a similar under ice global ocean. That brine is being delivered above the surface. Much of it falls back as this beautiful snow, making Enceladus one of the brightest objects in the solar system. But some of it goes on and forms one distinctive ring of Saturn's beautiful rings. The Cassini mission that was sent by NASA detected silica in this brine that is being released above the surface. And silica is distinctively associated with a lot of hydrothermal systems. These are places where we might have even had the origin of life here on Earth, though that is a big debate within that community. But these hydrothermal vents at the rock-water interface are very, very interesting. We initially thought that hydrothermal vents, these sorts of environments on Earth, would be sterile. These are unbelievable pressures down underneath the ocean. These hydrothermal vents are releasing things like toxic sulfide gas, and they have temperatures that are hot enough to melt lead. But when the first lights of the first submersibles that went down to explore these vents got there, they found this area teeming with life, and not just microorganisms, but these long 2-meter tube worms with these feathery red tops that were existing in this most unlikely world. And another place that we're spending a lot of time looking at is Titan, the largest moon of Saturn. And Titan is a world with pale hills and dark rivers and clouds and weather, and the only other place that has a very thick atmosphere, the only other moon that has a very thick atmosphere. And Titan is so interesting because it has a liquid on its surface, seas and lakes, but it's not liquid water. It's liquid ethane and liquid methane. It's a gasoline world where the chemistry is very different from the chemistry here on Earth, which really begs the question, what might the molecular or polymeric building blocks of life look like in such a place? So, for those of you that understand the Star Trek reference, if only we had a tricorder, some sort of instrumentation that would allow us to ask this question. And so even though we don't have that yet, some colleagues and I received $7 million from NASA to undertake a project really asking this question: how can we search for life without presupposing a particular molecular framework or a specific underlying biochemistry? Like all the life that we have here on Earth, it's the same life. It's all DNA-based. It's all carbon-based. We can pin it all onto the same phylogenetic tree. But what if that life had a separate origin and is very different? How would we go about looking for it? And in some ways, it's a wonderful challenge, like imagining a color that you've never seen before. But we've brought together a team that involves planetary scientists and veteran instrument designers, biologists and chemists, computer scientists and mathematicians. And we've been working together, and I wanted to just give you a quick taste of some of these approaches that we've been thinking about. One is this idea of just sheer chemical complexity. And as my colleague Lee likes to say, if you found a 747 on the surface of Mars, or even if you found a whole fleet of 747s, you may have no idea how they got there, but it probably wasn't random. So imagine that in a molecular context. If you found a very complicated molecule, much as a whole fleet of complicated molecules, perhaps there's a level of complexity above which it would be very, very difficult or perhaps impossible to create abiotically without life. And you might say, well, what exactly is a complex molecule? You can't just think of a heavy molecule, something with high molecular weight, because there are several heavy molecules that are simply polymers with repeating subunits that are all the same. But we've been using graph theory to develop algorithms looking at the sort of simplest number of steps, those kind of different ways you can build a molecule, and adding new steps to an index when you do something different. Not just add a repeating subunit, but add a new type of element or a new type of bond. And we found that although you miss many things that are biological, once you've done 15 different things to create your molecule, even when you go out and explore chemical space, everything above that is created by biology. And this little animation is just showing how we think about this for the molecule ATP. And on the right there, the kind of fragmentation pattern that new advanced mass spectrometers can deliver back to us, like the one that is about to fly on a NASA mission called Dragonfly, which is it's a quadcopter that's going out to explore that wonderful moon of Titan. We've also been working on my lab on an approach that combines the new advances in sequencing technology. These used to be huge benchtop instruments, and now we can hold sequencers in our hand that weigh only 85 grams, that are 10 centimeters long, and take 1 watt of power. We use them out in the field. This one is out in Antarctica. But instead of looking for DNA or RNA, these kind of specific nucleic acids that are involved with life as we know it, we have been working on taking libraries of millions of these very short, randomly generated oligos, 15 to 70 base pairs in length, single-stranded nucleic acids, which naturally curl up and have secondary and tertiary structures. And these, as we know from the RNA world, they'll bind to all kinds of things. They'll bind to clays and other minerals. They'll bind to peptides and small organics. They'll bind to metals and all kinds of ligands. And now imagine the vast amount of information that is patterned on the surface of even the most primitive cell here on Earth. There are all kinds of things that these short oligos, which again we are using simply as reporters, might bind to, versus, say, a simple mineral grain, which is a sort of repeating crystalline structure. And when we take these huge libraries, some very small proportion of them, far less than 1%, will bind, but with the same sort of specificity as antibodies. And we have a technique for removing those, amplify them millions to billions of times so we can see that signal, which is very exciting in the sense that we can use this instrument that is really designed to look for life that is related to life on Earth in a new way by, again, looking not for DNA or RNA-based life, but from these patterns of binding, which could show us the kind of complexity of this particular surface. And we're pushing beyond this as well to look for chemical sensing. By adding these R groups onto what we call oligourethanes, we're able not only to say this is a complex surface, but this is an aliphatic surface or an aromatic surface, which is very exciting. We've also been working on this idea of chemical fractionation, where you could have an elemental or an isotopic accumulation in a compartment that would separate a cell from its environment, regardless of exactly what that chemistry is. What's so interesting is at the microscale, we know that life concentrates scarce elements into these discrete entities that are very different from, say, the abiotic precipitation of marine calcite. But we also know at the macro scale, there's something called a Redfield ratio, this incredibly precise ratio that is 106 to 16 to 1 in terms of carbon to nitrogen to phosphorus. And this is extraordinary at the bulk level of seawater in the ocean. Even after you've got death and decay, the signature is so well preserved from life being part of that ocean. And we've been looking at ways that we might even discover Redfield ratios for exotic fluids around other worlds. We've also been thinking about energy transfer in the context of extant or still living life. There was a famous physiologist who once said life might be nothing but an electron looking for a place to rest. And would the current density and the other electrochemical properties of a life form harvesting electrons from its environment be distinct from something like abiotic oxidation? And it turns out the answer is yes. We've been working very closely with our colleagues at Harvard and designing the types of probes that you might be able to insert at one of those rock-water interfaces to look for these kind of electrochemical signatures. And I will say, with using these, what we're calling agnostic biosignatures, we must be willing to trade the sort of definitiveness that we would have from a DNA sequence or a molecule like a hopane for being more inclusive. But fortunately, when we send space missions, we often send a cluster of instruments, say 7 or 8, instead of just one. So we've been working very closely with our computer science colleagues on these Bayesian networks, how we can combine data from multiple approaches, and how we can convert these sort of measurements into probabilities, moving us toward sort of thresholds and likelihoods, instead of saying, well, we must have this binary life or no life detection. Maybe we can say, well, this is 3 standard deviations away from what we would expect from random processes alone. So let's follow up there. And so I wanted to conclude with just these 4 thoughts that I thought are relevant to this workshop at large. One, returning to this image that I started the presentation with. This is a sunset on Mars, and I remember seeing a similar picture from the Opportunity rover when I was in graduate school, and it was so baffling. It was just this incandescent blue, the exact opposite of what you expect. And even though I understand the sort of physics of the system, it's a type of scattering called Mie scattering that overwhelms the Rayleigh scattering here on Earth, it still took my breath away. And I think that we will be surprised, we have been surprised, and we will continue to be surprised. And in part because we have our own human perception. And I love this passage from William Blake, from his Marriage of Heaven and Hell, where he talks about how we see through the chinks of our cavern. And I tend to think about the universe in a similar way. Second, I also think we may just be toddlers when it comes to understanding what life even is. I have a colleague, a philosopher named Carol Cleland, and she says it's even premature to even attempt to define what life is. It's almost like trying to define what water is, but imagine trying to do that before you understood chemistry, before you understood what 2 hydrogen atoms and 1 oxygen atom were, before you understood what van der Waals forces between several molecules of H2O are. You know, we could describe water, we could say it's wet, but we're really confused when it comes to things like, well, is purple water water, or is ice water? And maybe we're at a similar place with biology. Again, we have 1 data point. All the life is the same life. We can trace it back to a single last common ancestor. And imagine if we had a second data point, or even more than that, to sort of help us understand, are there underlying laws for biology? Are there constraints for which biology must follow? Third, just emphasizing how incredibly ephemeral we are. I love this image. It was also taken by that Cassini spacecraft. That little dot there is Earth. It's our home, our world, our pale blue dot. Carl Sagan had a similar picture taken from the Voyager 2 spacecraft, and he wrote about it. You know, this is everyone you've ever known. This is every king. This is every mother and father. This is every emperor, every supreme leader. This is every sinner and saint that has ever lived out the entirety of their life in this teeny mote of dust. I just like this picture better because it really gives you a sense of the neighborhood. And the world will survive the Anthropocene. Life will certainly survive the Anthropocene. Our species will collapse into a layer of strata, just like all the species that have come before it. But the real question is, will humans persist to experience what comes next? And again, the universe is so enormous. As Guido talked about, with all of these exoplanets, we have more than 5,000 confirmed, these worlds around other stars. We also now think that there are probably 40 billion planets within our solar system alone. And imagine the types of life that these might hold. What if there was a type of life that had no Darwinian evolution, a type of life with no death, a type of life that didn't even have a separation from the environment? Or maybe life is common. Maybe life is just a product of energetic systems, and we'll see it everywhere. It's so exciting, those 40 billion, again, within our Milky Way galaxy alone. That's a solar system for every human being alive on this planet. And you may say, well, these worlds are so far away, and the universe does have a speed limit, and it's very slow. And what will we ever know of these worlds besides some sort of aberration of light, maybe a little something about their atmospheres from spectroscopy? But of course, this is what we also thought 100 years ago, a mere lifetime ago, when we were looking up through telescopes at the surface of Mars. And my last slide here is just that, like the universe, human possibility goes on. And just to imagine within one human lifetime, the idea of knowing these worlds intimately, of really understanding them the same way we understand our own planet. That went from the realm of complete science fiction. And this last generation has explored all the known worlds, all of the planets here in our solar system. And you just think, what might the next 100 years, the next one human lifetime bring? So I will leave it there. Thank you so much for having me to speak.
Molte grazie anche per questa importante, interessante, forse per alcuni di noi anche novità e sorpresa nell'affrontare i misteri dell'universo e della vita. Non ho ancora capito se l'universo si svilupperà o imploderà, ma d'altra parte nella Bibbia si parla di cieli nuovi e terra nuova, quindi c'è una speranza anche oltre questo universo. Ma adesso credo che sia buono anche prendere un caffè e quindi 20 minuti di pausa, 20 minutes, so 10 to 5, alle 10, cioè alle 5 meno 10 riprendiamo. 20 minutes, 20 minuti.